Let's start with the silo filling. A land-based blower with dry air is connected to the silo via the truck. The silo filling process is fully automated and controlled by pressure sensors and valves to protect the silo and its components. Load cells guarantee an accurate weighing, which leads to accurate traceability. All this is controlled by a touchscreen HMI. Spiromatic composite silos are unique in its design due to the 70-degree angle outlet cone, the extremely smooth interior wall, and the unique design vibrating discharger, which leads to a first-in, first-out extraction. For bulk goods like sugar, Spiromatic builds double-walled insulated composite silos. Sugar dust hardens dramatically with the presence of moisture. Therefore, Spiromatic composite silos considerably reduce the risk of lumps forming and powder sugar sticking to the wall. The combination of dry air, the unique double wall, and the insulating characteristics of composite prevents condensation. The discharge system with lump breaker ensures excellent extraction. Whoa! I hope you don't have a fear of heights, but you've got to see this. Did you know that composite is the most hygienic construction material, and it offers a much better resistance to overpressure than other materials such as steel? The automatic control dust filter is easy to maintain and specially designed for outdoor applications. On the rooftop, you can also see the manhole, explosion panel, and safety valve. Spiromatic composite silos comply to ATEX and are equipped with all necessary components to work in a safe and food-approved environment. Every silo is designed specifically for the bulk ingredients characteristics. Let me show you some special features of the sugar silo. A special insulated dust filter consists of anti-static envelopes to resist to moisture and keeps the filter envelopes free of sticking sugar. For silo filling, we selected a customized filling pipe to avoid powder sugar. A typical part of Spiromatic's hybrid conveying solutions is spiral conveying. This unique conveying system transports the food ingredients in a hygienic and dust-free environment. Spiral conveying moves the ingredient gently and doses it very accurately without any heat buildup and leaving no residue of old material in the pipe. Spiromatic rotary sifter capacities range from 1.5 up to 10 tons per hour, starting from a mesh size of 500 microns. The unique wedge wire basket prevents foreign particles entering the food chain and delivers a homogeneous product flow. Spiromatic sifters are an indispensable part of food safety, and therefore, we have designed them for easy maintenance and inspection. On the right side, you can see how easy it is to maintain and clean the basket. Let's go back to the sugar. Sugar is transported with a custom-designed hygienic screw from the silo. It feeds a vibrating sifter and keeps the sugar undamaged, which avoids creating powder sugar. Vibrating sifters have a very gentle sifting action, and its modular design allows quick and efficient cleaning. To allow continuous production, a sugar big bag can feed the sifter when the main silo is undergoing maintenance. A second sifter works on the same principle and is only for the handling of bran stored in big bags. Spiromatic's big bag discharging stations are designed to work dust-free. Be careful, an automatic crane will lift the big bag safely above the vibrating discharger. The dust-free connection ensures a contamination-free product flow while discharging and guarantees a food-safe operation. Non-free flowing ingredients like bran need a gentle extractor. Spiromatic ensures food safety, ergonomic design, and safe working conditions. Minor and micro ingredients can be discharged into buffer hoppers via a controlled manifold system. To open the correct filling pipe, the bags are scanned and registered. The scanning process guarantees that the correct ingredient is sent to the corresponding hopper. The PLC system keeps track of the consumed ingredients to allow traceability. All ingredients are sifted via a vibrating sifter with a central de-dusting filter to allow the operator to work in a dust-free environment. By preparing a batch recipe, the minor and micro ingredients can be dosed simultaneously. Every hopper is equipped with a dedicated extraction system, depending on its free-flowing specification. The spiral dosing systems are feeding the different micro-weighing hoppers at the same time with very high accuracy. This unique Spiromatic design of micro-ingredient feeding gives maximum flexibility combined with exceptionally high output. From here, the pre-dosed micro-ingredients recipe will be vacuum conveyed to the mixer. One of Spiromatic's most unique processes is hybrid conveying. Hybrid conveying combines the advantages of both pneumatic and spiral conveying in order to design a stress-free conveying process. In this process, the flour is dosed by spiral conveying to a sifting system from which it is then pneumatically conveyed to the buffer hoppers in front of you. Likewise, the sugar and bran is stored in the corresponding buffer hoppers. The flow is perfectly controlled by the central PLC system. Let's focus on the liquids process. Before we liquefy our own yeast, we will first clean the yeast tank. From the CIP recovery tank, we pre-rinse the yeast mixing tank via a hygienic spray ball and drain it. After flushing the yeast tank with water, we CIP the pipes and yeast tank with lye. Pipes and tanks are finally rinsed with clean water. To minimize waste and costs, this water is recuperated in the recovery tank and used for the next CIP process. Now we're ready to make our liquid yeast. First, we dose the cold water and then we add the correct amount of powdered yeast. An agitator makes a cream liquid yeast while the tank is chilled. Finally, the liquid cream yeast is stored in the chilled holding tank from where it can be used in a circulating loop at the right conditions. Time for something new, sponge dough. Sponge dough is prepared in advance so it can ferment for 4 hours before it is added to the main dough. In this process, the sponge production and fermentation is made continuously by the IDROMIX inline dough mixer. Flour is dosed in a turbine where a mixture of water and yeast hydrates the flour to a very high level, adding minimal energy to the dough. The continuously produced sponge dough is stored in dedicated fermentation tanks. Sponge dough is prepared in advance so it can ferment for 4 hours before it is added to the main dough. Once the fermentation tank is filled, a fully automated pig system will clean the pipework from IDROMIX to tank. This prevents fermentation in the pipes and recovers the remaining sponge. At the end of the fermentation process, the sponge dough is cooled in line whilst being pumped to the holding tank. The empty fermentation tank is rinsed before filling with a new sponge dough. Before final mixing, the pre-weighed minor ingredients are vacuum conveyed to a reception hopper. Major dry ingredients such as flour, bran, and sugar are dosed accurately by spiral conveying into a weigh hopper. At the same time, the water vessel receives the correct water volume and at the right temperature. We're getting to the final mixing stage. The minor ingredients are discharged to the major dry ingredients weigh hopper, which is directly connected to the high-speed mixer. Alongside the solids, we handle the liquids. The prepared quantity of water is then added directly. On top of that, the sponge dough, liquid yeast, and oil are simultaneously dosed. In a minimum of time, we have filled the mixer. The high-speed mixer can now finish the final dough. Meanwhile, a new ingredient batch is being prepared. At your right side, you can see an example of a traditional dough mixing system, improved by robotizing the mixing bowls. By robotizing the bowl handling for dough resting, you save space by storing the bowls vertically. After fermentation, the bowls are brought back to the line for dough makeup. The benefits are less space needed, higher output, hygienic floor space, flexible bowl cleaning. At your left side, we go a step further. The robot is combined with an inline IDROMIX dough mixer and a fully automated carousel. The IDROMIX dough mixer has unique features that are very promising for future dough processes. Flour is dosed in a turbine where a mixture of water and yeast hydrates the flour to a very high level, adding minimal energy to the dough. IDROMIX can hydrate the dough up to 2% more than any other advanced and much more expensive mixing systems. As a result of this highly hydrated dough, IDROMIX can reduce the mixing time by up to 40%. This means 40% less energy input and cooler dough temperatures. This also means that the final dough mixing can be done on simpler automated mixing systems. Of course, the IDROMIX can also prepare the ideal pre-dough, biga dough, or poolish before the final mixing. Flour cooling is essential in frozen dough production or in some regions or periods of the year where the flour temperature is high. Spirox is the best performing flour cooling system due to its high cooling capacity with minimal energy input. With only 70 kilograms of CO2 per ton of flour, Spirox can cool down flour by 10 degrees Celsius. While the flour is conveyed in line by a Spiromatic spiral conveyor, 6 nozzles are sequentially spraying CO2 snow on top of the warm flour. At the end of the Spirox cooler, the requested flour temperature is achieved and can be dosed directly into the weighing hopper. As a result of an energy efficiency of almost 100%, flour temperature differences of up to 20 degrees Celsius can be reached. At the outlet of the Spirox, the CO2 gas is extracted in a safe way. Therefore, it is the optimal solution for a constant dough quality.